Hi everyone. Today we're going to study probability using tree diagrams. First, let us define tree diagram. A tree diagram is a special type of graph used to determine the outcomes of an experiment. It consists of branches that are labeled with either frequencies or probabilities. Tree diagrams can make some probability problems easier to visualize and solve. Let us have an example. In an urn, there are 11 balls. 3 balls are red, denoted by R, and 8 balls are blue, denoted by B. Draw 2 balls, one at a time, with replacement. With replacement means that you put the first ball back in the urn before you select the second ball. The tree diagram using frequencies that show all the possible outcomes follows. This is an example of a tree diagram. In this level is considered to be the first draw, where there are 2 branches. The first branch represents the 8 balls. The second branch represents 3 red balls. On the next level is the second draw. Please note also that the problem says that the first ball is being replaced in the urn. That's why you see here there are 2 branches here under the blue balls. In this first branch, there are 8 balls. In the second branch, there are 3 balls. On the second group of branches under 3 red balls, this first branch here represents the 8 balls. The second branch represents the 3 red balls. Now, regarding the number here, this is 64 BB. This means the 64 comes from the product of this 8 and that 8. And this BB means the first draw is a blue ball and the second draw is also a blue ball. Here we can see 24 BR. The 24 comes from the product of these 3 and 8. And this BR means the first draw is a blue ball and the R is red ball. Here we have 24 RB. The 24 comes from the product of 8 and 3. And this RB means the first draw is a red ball and the second draw is a blue ball. In here we can see 9 RR, and this 9 comes from the product of 3 and 3. The RR means the first R comes from the red ball in the first draw and another R for the red ball in the second draw. Now, if you write the total of this 64, this 24 plus this 24 plus 9, the total will be 121, and this is the number of elements in the sample space. We can list each red ball as R1, R2, and R3, and each blue ball as B1, B2, up to B8. Now, as an example, for this 9RR, the 9RR outcomes can be written as R1, 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 R2, R1, R3, R2, R1, R2, 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 R3, R3, R1, R3, R2, and R3, R3. Let's go now to probability using tree diagrams. Let us have an illustrative example. An urn has 3 red marbles and 8 blue marbles in it. Draw 2 marbles, one at a time, this time without replacement, from the urn. Without replacement means that you do not put the first ball back before you select the second marble. Here is the example of our tree diagram. We can see here that the branches are labeled with probabilities. This first level is the first draw of marble. The first branch here represents the probability of taking a blue marble. We can see here this is 8/11. There are 8 blue marbles in the urn and a total of 11 marbles in it. The second branch represents the probability of taking a red marble. There are 3 red marbles in the urn, so this is 3/11. Again, that 11 is the total marbles in the urn. This second level here is for the second draw. There are 2 groups of branches. This first group represents the probabilities when the first draw is taking a blue marble. So here we can see that the first branch represents the probability of taking another blue marble. We can see here that this is 7/10. Remember, in the problem it says we are not replacing back the first marble once we get the first draw. It means there is an assumption that the first marble is blue, so there will be only 7 left in the blue marbles. So this is 7/10. Also, before the total is 11, since we are not returning that first marble, so 11 minus 1 becomes 10. So this is 7/10. The second branch here represents the probability of taking a red marble. There are 3 red marbles over 10. The second group of branches represent when the first draw is a red marble. So this branch here represents the probability of taking a blue marble in the second draw. And that is, we have 8 blue marbles over 10. The second branch represents the probability of taking another red marble. So from 3 marbles total, we assume that the red marble is already taken. So that is 3 minus 1 is 2 over 10. The numbers at the ends of the branches are calculated by multiplying the numbers on the two corresponding branches. Here is one probability, 56 over 110, and this represents BB. This BB means the first marble is a blue one, and the second marble is also blue. The 56 over 110 is the product of 7 over 10 and 8 over 11. So we have 7 times 8 is 56, and then 10 times 11 is 110. The second probability here is 24 over 110, and this is BR. This is the probability when we have B means blue in the first draw and R in the second draw, or R means red marble in the second draw. Also, this 24 over 110 is the product of this 3 over 10 and 8 over 11. So that is 8 times 3 is 24, and 11 times 10 is 110. Another probability is 24 over 110 for RB. RB means the first marble is red, the second marble is blue. 24 over 110 comes from the product of this 8 over 10 times 3 over 11. That is 3 times 8 is 24, and 10 times 11 is 110. Last is 6 over 110 corresponding to RR. It means the first marble is red and the second marble is also red. The 6 over 110 comes from the product of 2 over 10 times 3 over 11. When we take the total of the probabilities down here, we will have this 56 over 110 plus 24 over 110 plus 24 over 110 plus 6 over 110. We can see that we have like fractions and the common denominator is 110. So we can simply add the numerators, and this is equal to 110 over 110, and that is equal to 1. We can see now that the probability of drawing 2 marbles, of course this is without replacement, such that letter A, both are blue, is 56 over 110. It comes from this fraction here. Letter B, when the first marble is blue while the second marble is red, the probability is 24 over 110. Letter C, the first marble is red while the second marble is blue, the probability is 24 over 110. Letter D, when both are red marbles, the probability is 6 over 110. So this is our final answer. Let us have another example. Two coins are tossed together. Find the following probabilities using a tree diagram. Letter A, probability of getting 2 heads. Letter B, probability of getting at least 1 head. Letter C, probability of getting at most 1 head. Letter D, probability of getting exactly 1 head. Let us write our tree diagram. Let's begin with the first coin. In the first coin, there are 2 sample space, and these are head and tail. The probability of getting a head is 1/2. The probability of getting a tail is also 1/2. Now, in the second coin, there are 2 possibilities also. The first possibility, when the second coin turns head, and that probability is 1/2. The second coin may be tail also, with a probability of 1/2. Now, for the second group of branches, where the first coin is turned tail, for the second coin, there are 2 possibilities. It may turn head or tail. For the head, the probability is 1/2. For tail, it is also 1/2. Now, let us multiply the probabilities. So, turning head in the first coin and turning head in the second coin, that is 1/2 times 1/2. And the answer is 1/4. Now, here, when the first coin is head and the second coin is tail, the probability will be 1/2 times 1/2, and the answer is 1/4. The next is, when the first coin is tail and the second coin is head, the probability is 1/2 times 1/2, and the answer is 1/4. And the last, when the first coin is tail and the second coin is tail, the probability is 1/2 times 1/2, and that is 1/4. Now, using these probabilities, let us now answer letter A, probability of getting 2 heads. So we will write P of 2 heads, and this is equal to 1/4. This is the answer. Now let's answer letter B, probability of getting at least 1 head. Getting at least 1 head means it can be 1 head or 2 heads. And this is equal to 1/4 coming from 2 heads plus 1/4 when there is 1 head and a tail in the second coin, plus 1/4 when the first coin is tail and the second coin is head. So we can see here 1/4 plus 1/4 plus 1/4. And the answer is 3/4. Let us go to letter C, probability of getting at most 1 head. This means the probability of getting 0 head or 1 head. This is equal to 1/4. It comes from when we have head in the first coin and tail in the second coin. Another 1/4 comes when we have tail in the first coin and head in the second coin, plus 1/4, and this comes from tail in the first coin and tail in the second coin. So we have the answer as 3/4. Letter D, let's take the probability of getting exactly one head. And this answer will come from 1/4. This 1/4 comes from when we have head in the first coin and tail in the second coin, plus another 1/4, and this comes from tail in the first coin and head in the second coin. So we have 1/4 plus 1/4 equals 2/4, and this 2/4 can be simplified into 1/2. So we are able to give the answers in all our problems in example 2. I hope you learned something from this video. See you again next time.